if you are a depressed teenager, hopefully you're not, what you do is you say, oh no, I'm sad, and you look downwards, right? You do not do this. That would mean like you're happy, like you're getting joy in your life if you're looking upwards, right? So what will happen is, sorry, I didn't mean to offend all the depressed teenagers here, but if you do, what happens when you say depression, half the class is going to find this angle. That is not depression. Right? The angle of depression is looking across and looking downwards rather than measured from the from up and down. So what that means in a lot of cases, the angle of depression is going to be outside the triangle, right? And that's what the difficulty is here. Now this is our first difficult question we had to deal with this year. Sorry, yeah. Right? And the building at 90 degrees. Yes. Okay. So we're going to have what's called the top view and the side view. This little interjection. Okay. On the top view. Okay, this is like looking from heaven. When you look at me and the CN Tower from heaven, you know what? We look pretty much the same. Okay? The only thing you can see on the top view is north, south, east, west. Yes. I'm going to say top view, we'll say. And horizontal distances. Okay, right? Let's say there is you're tipping a ladder from a house like this. Okay, you won't see the ladder. What will you see if you're looking at this from outer space? A gray dot. No, not really. What do you see if you're looking at this from outer space? What will you only take a look at? You only very good. You only see the horizontal part of that. That's all you're going to see. Right? So anything that any hypotenuse or height won't have any meaning to you when you're looking at from the top view. From the side view. This is going to be angles of elevation, depression. And again, only, and that's it. Horizontal, vertical. Okay. So from the side view, again, if you're looking at me and I'm facing this way, can you tell if I'm facing north, south, east, or west? Well, unless you're Nicole and you know all that stuff instinctively. But for everyone else, though, if I'm pointing this way, you have no idea. I'm just facing forward, right? So, and that's the way you have to look at these, right? North, south, east, west only is meaning from the top, not from the side. Now, what is the only thing that's connected between the top view and the side view? It's only one thing. The horizontal distance is the only thing. So that's how we're going to make these triangles. That's going to be our connected side. So if you look at the last example where we had the hypotenuse was connected on both of them, the same thing here. The horizontal distance is going to be the only thing that connects the three dimensions together. Okay. So we will have one triangle, at least one triangle from the top, and at least one triangle from the side. That's what this is going to do. So let's go back to our word problem there. Okay. So it says, I move these around here. Does everyone have this scribbled here? Because this is relatively important, especially the top two sides of these things. Okay. Because we're good. Looks like me. Just the internet doesn't know what I look like, so I went for a perm instead of my regular long hair. Okay, so that's all right. I want a perm. Okay, here we go. I'm going to actually start drawing my diagrams here right now. I'm going to move this across here. Whoops. Oh goodness, what's going on here? What is even happening? Where am I? Oh, does that work? It works. It works. Lovely. It's sluggish. Okay, so is everyone done with the left-hand board? Done with that? So I want to leave this diagram. Okay, so here we go. We're going to do the top view and the side view. Wait, can I get someone to be brave and tell me something that I know about my top view? Yes, go ahead. Angle is 35. Good. So what I'm going to do is, here's my firefighter. I'm going to call this fire 1 for F1. Okay. So that's going to be 35 degrees. Is there anything else that we know about the top view for that first fire? Is there anything else we know from the top view? Do we know the horizontal distance? No. Do we know F is, sorry, forest fire? This is that, fire one, fire two, a lot of F's there, okay? Okay, but the idea is there's nothing else we know because we know things about the angle of elevation. Sometimes we know how high the fire is or how low the fire is, but we don't know anything else on the top view for that.
Which one's the firefighter?
FF is the firefighter. Okay. Let's keep going with the firefighter. Let's do the side view of the firefighter in the first fire. Okay, what do we know about the firefighter? Someone other than Liam here. On the side view in the first fire. Tell me something that we know. Someone go ahead. Okay, good. So where's the angle of depression from? Where to where? Yeah. So the angle of depression is, here's my firefighter, we're trying to call FF. And the angle of depression goes something like this. And what was that, 8 degrees? 11. Okay, so everyone see that? Okay, the angle of depression is not measured inside the triangle, it's going to be like that. What else do we know about this? Yeah, go ahead. Yes?
Does it matter if it goes like this way or this way?
No, it doesn't really matter. I'm right-handed, so I always draw my triangles like that. Remember I said I can't draw a decent triangle, so yeah, as long as it looks, you could have had the firefighter here and 11 degrees down there. That's the same thing. Okay. What else do I know? One other thing. Play along, please. What else do I know? Someone other than Summer and Liam. Yeah, Chris, go ahead. 15 meters high, okay? Now here's the key point. Okay, so if you're fading out, this is the time to fade in. Oh, that's the right angle too. Sorry, my triangle is awful. Sorry. What is shared between the triangle on the bottom and the triangle on the top? Is there anything shared? Yeah. No.
Fire.
Sorry, I didn't say that. I'm sorry, incorrect. What did we say on the left-hand border is the only thing shared between these two triangles? What's always shared? Horizontal distance, okay? Because if you look at the hypotenuse, I'm going to call that y, I'm going to call that y. Really what this is, I'm going to draw the 3D view here in a minute, okay? Should I do the 3D view now? I'll do the 3D view now. Some people like the 3D view. So here's my firefighter down like this. That's the 3D view of what's happening there. It's hard to see. Alright, so then what's going to happen is the other fire will be down here. So here's your first fire. If you don't like that, don't worry about it. I'm not a good artist. Don't worry about it. I'm still glad that wasn't there. Keep going to the second fire. Okay, what's my top view for the second fire, please? What do I know about the second fire? Put this in blue. Now I'll put that back if you want to see the 3D view after, okay? Some people are good 3D viewers, I'm not. Drawers. What else know about the second fire, please? From the top view. I know one thing, come on guys, play along. Everyone's going to do this. From the top view, what else do you know about the second fire? 20 degrees to the east, okay? So I'm going to actually connect this. And there's F2. Ultimately, we're looking for this distance on the top, which is x. Okay, that's the only thing we're actually solving for, is the distance from the two fires apart. Excuse me, can somebody tell me what I should put in the side view for this one? Okay, so I have 13 meters. There's my firefighter. Okay, what else do I know? And pressure is 8. Please note these diagrams are not to scale, so that's like a 30-degree angle. Okay. And that's all I know. What side is connected? And there's fire 2. What side is connected to my top triangle? Oh. T. T? Alright, I'm going to call it that. Or do you have scissors on them? You do have scissors? Hello,
You sever. Every time it's a question with a 90-degree angle, so every time someone's standing on a building, is the angle of compression always going to equal the angle of the bottom angle there? So like after I'm going to 11 after
Okay, for those who are having a hard time visualizing. The internet doesn't need to hear this. This. Now I want to hopefully solve for x. What do I need to solve for x? Oh, sorry, here's just the back. What do I need to solve for x? Come on, guys, play along, please. Tristan, you've been very quiet today. If I want to solve for x, what's the first thing I need to find? Some side lengths would be good. So what I need to do is I need to solve for y and z, and then we're going to do cosine law. Okay? So what I'm going to do here, first of all, I'm going to put some angles in here. I'm going to call, thank you. I'm going to call that 79 degrees. How do I get 79 for that?
That's a good question.
Because, yeah, it's always going to be a right angle like that, okay? In the same way, I'm going to call this 82. Okay? On the left-hand side, I want to quickly say tan of 79 is y over 15, and tan of 82, just pop this on the thing, equals z over 13. Now again, if you say, I don't like tan, I like sine law, good for you. You can use sine law if you want to. Okay, right, but we'll always use tan on the board. All right, you'll still get the same answer as me. Because trig works. Well, no, we're still taught. Here's your opposite, and there's your, and there's your opposite. Okay, so y equals 15 times tan 79. Z equals 13 times tan 82. That looks like a 2, but that's actually a Z.
Is there an advantage or disadvantage using sine law versus tan law?
I just like SOHCAHTOA, so.
Okay.
Alright, so this should be 15 over y. This should be 77.1683. So we confirm these for me? Yeah. And this should be 92.5. What's that? That's supposed to be a Z, sorry.
That's what I was thinking too.
Hey, don't tackle me. Okay, whoops, 3D view. Let's get rid of that. Let's get that wasn't there, okay? Some people like 3D views, I don't. Fairly well.
Oh, yeah. No, like correctly, it's not your drawing, it's 3D view.
So that's 54 degrees, that's 77.1683, that's 92.5, and that's x. So x squared equals 77.1683 squared plus 92.5 squared minus 2, 77.1683 times 92.5, so it's 54 degrees, and I got 78.23. I'm going to take a step back, maybe there's a chance to finish up.
Okay.
That was just math, that was just grade 10 math, is all that was.
35 and 1 day. It's
Yeah,
actually 54. It's 56.
Yes, 56.
What? The inside angle is 56.
I don't think it's 54.
I don't know.
Is there anything wrong with them?
Yeah.
What?
Well, at least in the top.
What? Right now?
Can you use timeline?
Are you timeline so well?
You what?
I
No, like so I calculate the y.
I use 10.
What is this equal to?
I got 80.
Yeah, I can't add, so I have 54 on my page. Look at this, it's something big.
Alright. Plus 21 is not.
Yeah. I'm sorry, you guys are right, I'm wrong. Dang nabbit. The whole internet will know I can't add. Yes. Yes, sir.
Well, In that blue triangle,
Yes.
the Z, that is like the Z on the top
Yes.
view, from like FX to F2, so why
Yeah.
isn't it on the blue?
It is. It's the horizontal though, right? Right. So think if you're looking down from 100 miles away, you're not going to see a hypotenuse, right? All you're going to see is the bottom. If you're looking at the way you got to think about it, let's say pretend I have a ladder tipped up like this. Okay, it's a beautiful ladder. It's 20 meters tall. You're looking at this from outer space. What are you going to see? All you're going to see is a little chunk at the bottom. That's all you're going to see. Right? You're only going to see a little shortened version. But this is a beautiful box of Kleenex. It's very big. If I tip it like this to you, what do you see? You only see the little horizontal part of it like this. Okay, right? Like you don't see this beautiful hypotenuse. Right? The only length that you will see is a little tiny bit.
Yeah.
Pen, right? How much of this pen do you see now? Yeah, what sort of distance you're seeing? The point is you're only seeing this much distance of it, though, right? Like you're not seeing that you can't judge that it's this big when it's tilted like this. You have no idea how big it is, right? If it is, you know, you can only see this much of it. You know? The point is that you can't tell. The point is when you're looking at this from a while up, you can't see this length, right? This isn't the length that you can see. You can only see the horizontal length. That's what I'm trying to say. Right, so the horizontal length and the horizontal length. What is our actual answer here? Did I work it out yet?
I got 160.
How much?
I got 84.
Oh my goodness. So wrong. Okay, we gotta get Spidey. I want to do one more example here, so we gotta keep moving here. Let's do this quickly. So, 77.
Wow. Did anybody get 84? Dang it.
Yeah, it's just.
Plus I got 70.
It's negative 2,000 XP.
80.8 is the answer.
Okay. I got different measurements for the stars.
Did anyone get 80.8?
Yeah.
Very good. So I'm
This is all rounding.
Okay. Okay, I want to move on to the Spider-Man question here in a sec. Okay? Because this is another example of this. Now, these are conceptually difficult, as you're probably seeing right now. Like, these aren't easy, right? You got to really focus on these. The idea, the best suggestion I can give you for this is to think top view, side view. Top view is just north, south, east, west. Side view is everything else. Okay, normally there'll be 3 or 4 triangles that we're drawing on this. And we're not getting the 4th dimension, all that weird stuff. We're not doing any of that today. But the idea is, though, we're top view, side view is what we're thinking of here. Yes. We don't need that anymore. We're looking for this distance, so you are. You're always looking for the horizontal, right? You're always we're always looking for the horizontal.
Okay.
Okay, let me hit stop in the video, then we're gonna try example 3.